I'm a PhD candidate in the Rangel Honeybee Lab at Texas A&M University, where I'll be graduating in December with my yeah, hopefully a USDA honeybee lab. We'll see. So this is my 13th year as a beekeeper. Interesting, superstitious stuff going on to graduate this year, I guess. But so occasionally I pretend I know what I'm talking about. The bees don't always seem to read the same books that we read, and that makes life interesting. But I do try and tailor my talks to my audience as much as I can. And so in light of that, how many of you are first-year beekeepers? Okay, a lot of this is going to be over your heads sometimes. So if you have a question come up that you think is going to impede you from understanding more, please raise your hand and ask. If it's a question of, well, are you sure about that, or how do you know that, or then wait until the end for those, because I can tell you in a lot more detail then than if I'm crunched for time and trying to get to the next slide, okay? Because I really welcome those, like, how do you know what you say you know questions. Don't ever lose that willingness to ask those. That's vital. How many of you are second-year beekeepers? Raise your hands. Okay, so a few of you. How many of you have beekept between 3 to 5 years? Quite a few of you. How about 5 to 10 years? I guess 6 to 10, huh? How many 11 to 15?
Is that continuous beekeeping going?
I was just gonna say, when I get a level that nobody says, then I'm like, how many more than 15? Anybody more than 15?
Continuous.
Yeah, Mr. Braley. All right. Well, he's very, model after him. He's very good at saying, how do you know what you say you know? Very valid skill. All right, so without further ado, they retitled my presentation for me, which I'm not sure if I should be pleased or not. But so basically, this was formerly entitled Practical Queen Rearing. How many of you have more than 10 colonies? Okay, so about half of you. Cool. So then we get to talk about everything because everybody is in the room. This is so great. So let's first talk about, we're all out of order. Okay, so first things first, we're going to talk about assessing colonies and queens and the quality of queens. Then we're going to talk about factors that can impact queen quality. Then we're going to talk about 2 queen rearing methods. One for small scale beekeepers and one for larger scale beekeepers. So without further ado, and this is where everybody groans. But there are some points that are super important, so important that you should hear them more than once. One of these is records. Records are a prerequisite to being a serious beekeeper. Some of you who have been beekeeping for more than 1 year are going to disagree with that. But as someone who has kept bees while keeping records and while not keeping records, I have to tell you that there's no way you can seriously know what's going on and how good a beekeeper you are unless you are keeping good records. And how many of y'all have heard of the, I'm a Texan now. How many of y'all have heard of the brick method of record keeping? So for those of you that didn't raise your hands, it's that idea that you keep a brick on your telescoping cover to keep it weighed down, and you'll change the orientation of it based on what that colony needs. It's cool to look up and be like, okay, I'm looking at my bee yard and I know that that one needs requeening and that one I need to check. Absolutely horrible in terms of record keeping. You can't know if your varroa control treatments are working or if the queens that you reared have done well. You have very little information that way. The other thing to know about queen assessment is that This is kind of an intermediate skill, but you've got to eventually be able to mark your own queen. Now, first years, I tell y'all not to worry about that. Your first year, you see eggs in that colony, and we'll talk a little bit about how to make sure that they were laid by the queen. But if you know that a queen laid eggs, there's eggs, larvae, and pupa in your colony, and don't bother looking through to find the queen. I think your first year, when you get so caught up in doing that, you're more likely to squash her than you are to get good information out of that. However, once you're an intermediate, and once you start trying to rear your own queens, you gotta be able to mark her. And that gets interesting sometimes, because sometimes people will squash her, which is why it's an intermediate activity. But how many of you have had a colony requeen itself that you know of? The majority of you. How many of you suspect you have had a colony that has requeened itself? Quite a few of you as well. I will tell you that bees requeen themselves without your permission all the time, and that you're never going to know if you don't mark her. We're going to talk a little bit about biology, because that's what I do, and because you can't be a beekeeper and ignore biology. And so for the record, let's talk about those first. I don't care if you're writing stuff down in a spiral notebook, if you're using a fancy app online, or if you're keeping some sort of other journals. Whatever you have to do, do it to keep records. And what sort of things should you keep records of? Any ideas? How about varroa counts? When you sample your colonies for varroa, which colonies normally have issues with varroa? That would be a good thing to know. What about colony growth? Has one colony really been lagging behind? Has one yard of your apiary been lagging behind compared to others? That would be a good thing to know too. Has a colony swarmed a month ago? All of those things are worth reporting. Okay, so we mentioned biology. How many days, here, cheat y'all, how many days does it take for a queen to grow up from an egg? 16. How often do you check your colonies? It's gonna vary. For me, it totally varies based on what time of the year it is. If there's a nectar flow that's on, I am out in my apiary. If there is not a nectar flow that's on, then I kind of let them do their own thing a bit. But this is vital when you are paying attention to your queens and when you're getting ready to rear queens. So, if you are going to rear queens, how many of you were at Dr. Deltwain's, it would be his second talk this morning, right before lunch? Okay. Not many of you. Good and bad, what are you guys doing? So in there he talked about 3 different breeding strategies. The most common of which, and the most that has room for error, is where you pair and are able to control the mother portion, the maternal genetics of your queen rearing process. But because of the biology of bees, unless you're inseminating that queen directly, you don't have control over the paternal side of that equation. So if you are going to rear your own queens, and inevitably you are going to have to at some point, you're going to have a colony that's going to go queenless. You might not be able to buy a queen at the drop of a hat. You don't inseminate, so this is how you're going to do it. If you have kept records, you can go back and you can say, this colony has a history of having the stuff, the traits that I want to have in my colonies. Well, that colony is the one you should rear a queen from. Do you follow me? So you get what you breed for, at least to some extent. So what are traits people breed for? I've seen people breed for survivor stock. Zia Queens out of New Mexico does that. She has queens that are 4 and 5 years old, and that is her norm because her entire breeding program is centered on longevity. temperament, varroa resistance, honey producers. These are all things that people breed for, and they can do it successfully if they quantify what's going on in their apiary and they consistently breed for it. Now, this is out of New Mexico there. Notice what I don't have. Yeah, temperament was the secondary trait that they were breeding for. So Dr. Delaplane very elegantly and very accurately said that breeding is a zero-sum game. Well, you can choose a couple of these things to breed for. You can't breed for every single one. Having a super bee is just not realistic. But Zia queen bees breeds for longevity first and foremost, but then also temperament. They have a joke that they really like their beverages, and that it's hard to drink a beverage in the bee yard through a veil. So you need a smoker or you need a veil, one or the other, pick. And so there are bees in here, and I'm just introducing virgins to you. Whoa, what about these? Yeah, these are on the Mississippi River in the Midwest. You can get massive nectar flows in that area, especially when you're on conservation land like these colonies are. But temperament and honey production are two of the most easy things to breed for, and that's probably because they've kind of been hardwired into the honeybee at a genetic and evolutionary level. So if you're selecting for honey production, you can do that. How do you know if you're selecting for honey production? Oh, you guys really are an after lunch crowd. Say it loud and proud. Records, guys, records.
Get your queen cell form. It has a lot of honey.
Yeah, and how do you know? You don't if you just kept bricks on the tops. You need to be recording how much honey you got from each hive. All right, so we've talked a little bit about these. So now we're going to play into, or I believe we will play a little bit more into the biology. So there are destructive and non-destructive ways to assess queen quality. So something you can put in your records. So some destructive ways would be looking at their spermatheca, counting the number of ovarials they have, so how many eggs they've got in their ovaries. Those are all things you gotta kill the queen to see. But there are non-destructive ways too, and one of those is examining retinue. Another is looking at the laying patterns. So let's chat about these for a sec. What if you see this in a colony? Whoa, bad things. This is a laying worker. This is a classic laying worker. There's multiple eggs in each cell. There's some on the cell walls. This colony is hopelessly queenless. What if you see that? Oh, that's gorgeous, guys. This is that very traditional classic crescent brood pattern where you've got the older brood, the pupa in the center of the frame, followed by a ring of older larvae and younger larvae and eggs, and then pollen, and then honey. This is great. This is what you want to see. If you're keeping records, you can tell, okay, this colony over here has a history of a gorgeous laying pattern. That queen has really done a solid by me. What if you see this? And this is a trick question, so be warned. What if you see this? You think that's a good queen or a bad queen?
Could be highly hygienic.
This is, yeah, it could be. So this is a trick question. At a first glance, I looked at this and I was like, oh, it's a shotgun brood pattern. This is what we call when a colony is relentlessly consuming queen-laid eggs. And so it yields a super shoddy brood pattern. And that might be because there are diploid drones in there. That might be because the queen is super, super hygienic to the point where it's a bad thing. That could be for any number of reasons. But this is where the trick came in. this isn't a shotgun brood pattern. Why do I say that? Well, look at this. What's in here? What are these glints? Yeah, these are nectar. What are these? That's pollen. This colony was really having a pollen and a nectar flow at the same time that the queen was laying, and they were competing for space in a really major way. Is this a good frame to talk about in your records and to say she's a great queen or there is no queen? No. So keep in mind the context when you're doing these assessments. Don't just write a queen off that she's bad because you see one frame. Don't say she's a great queen because I've seen one frame. Keep the environmental context in mind and use more than one frame over more than one time point so that you can compare across your records over a period of time, what is this queen like? All right, what if you see that? Yeah, she's a drone layer. She either never mated, if you tried to rear her and you see this, where you put her, you're like, oh, this didn't work out. Or she's old, she's run out of sperm. Or there's some sort of laying worker. Either way, it's bad news. And you can tell what one of those options is the reality in this colony if you look back at your records. What if you see that? Oh, that virgin queen that you introduced mated and life is so good. Okay, and then I am absolutely helpless to leave out every single bit of my dissertation, so I will say this one way that you can assess queens too. What do you think of this queen? She looks good. What do the bees think of her though?
Not paying any attention.
They're not really excited about her. They've got 2 bees in the bottom that might be antenating her. What about that queen?
Yeah.
Whoa, they love her. So, some really awesome work. Oh, I'm so geekily excited about this. So, the first chapter of my dissertation has been submitted to a scientific journal last week. And so, hopefully in the next couple of months, you guys will have the opportunity to read the paper where I share my findings that the retinue size that a queen has is highly correlated with her egg laying rates. So the larger the retinue, the more eggs she's laying. So cool, so cool. But I do want to interject one word of caution there. If you've got a colony this big, you've gone through the entire colony, you're at the bottom, I don't know why you did that much work, but for whatever reason, you've been compelled to find the queen, and she's in the lowest box. When I get to that point, I've been using a lot of smoke. What about you? Yeah. Well, and we use smoke because it confuses the bees a lot. It masks their pheromones, they can't tell what's going on. Queens attract retinue with pheromones. So if you have just heavily smoked colony, you're never gonna find a retinue like this ever. You might find this. So if you're really messing up the colony, don't use retinue size as a good measure. Okay? Okay. So we've talked a little bit about assessments and checking queens that don't do well and figuring out why they don't do well is a good idea. It's something that I think we're gonna skip over a little bit. I'm just gonna show you this one really, really rad picture that Cameron Crane took of my finger with 3 spermathecae on it. So in here, we discovered, once we took the spermathecae of the queens out, that one of them was a virgin. That might be why she wasn't doing well, huh? She never mated. If she had stayed in there and the bees had allowed her to live much longer, she would have been a drone lamb. Because that clear spermatheca with no sperm in it is what that means. Okay, so for you small scale beekeepers, this is what I advocate for queen rearing when you need to. I call it the cheater method. because colloquially as a beekeeping group, we normally call things like this the walk-away method, but I'm a little bit more micromanagey than your traditional walk-away method, so I call it the cheater method. In the spring, if you have an overwintered colony with swarm cells, make a split with it. Make a split with it. Take the frame that has those queen cells in it and put it in a nuc or a new box with a lot of food and a lot of brood and a lot of bees. And then keep that timeline in mind to find out more. So if these are the cells that you put into your cheater split, what do you know from this? So these are capped pupil cells. What is the maximum amount of time it would take for a queen to emerge from that?
11 days.
Well, 16 days from the time the egg is laid. So how much of this? Yeah, exactly. See, you know your biology. And see, it helps. Okay, so she could emerge today, but at the very most, she'd be emerging 8 days from now. That is vital to know because, as I said, I'm a micromanager, walk-away, splitter advocate. When you check in about a week, it's good to know what to expect. What does it mean if you make a split using these cells instead of these cells?
You'll have some of the queens.
Yeah, traditionally, this is what a supersedure cell looks like, and this is what a swarm cell looks like. Swarm cells are normally on the periphery of frames, and supersedure cells will be in the middle of frames. This is not always the case, but it is commonly the case. So, you take that frame, pack it full of bees and resources. So, put in frames that have all 3 stages of brood, or put in frames that cumulatively have all 3 stages of brood, the eggs, the larvae, and the pupa. Put them into a nuc is what I tend to do, along with a frame that is solid of food and maybe an empty frame. And walk away and come back about a week later, see what's going on. And introduce a new frame of brood if they don't have new queen cells going and there's no evidence that a queen emerged. So why do I advocate for this? I advocate for this because it's simpler for smaller scale beekeepers. It's so much simpler. We have enough time, guys. I have been using our time wisely, which is rarity. So be very excited. You'll see in a minute when we talk about grafting, what's known as the Doolittle rearing method, that it's incredibly expensive in terms of bees. You use a lot of bees to graft. And if you're a small scale beekeeper, that's just not a feasible option, especially when you only need a handful of queens. There's also a lot room for error when you use this method. So with grafting, you have to be very, very careful of what age the larvae that you graft are, and when they're emerging, and etc. And we'll talk about that in a second, but with this method, it can be the 8th day of a queen's life that you take her, or it can be the 16th day. You've got room for error. You don't need to know the exact day. So it's a lot more forgiving for beginning beekeepers. Now there is some talk about the difference in the quality of queen between swarm cells and emergency cells. And who was just at Dr. Delaplane's talk? So quite a few of you. So he kind of talked about this. And that's something really interesting because there has been one follow-up paper since that royal subfamily paper that he talked about. And they did not find evidence of a royal subfamily. I will say that there is quite a bit of evidence in queen quality and the quality of nutrition that they receive during their immature life stages. When I think of a colony that is undergoing supersedure, I think of a colony in distress. That might mean that they don't have very ample food stores. When I think of a swarming colony, I think of a colony bursting at the seams. I think of a colony so healthy that it's got to swarm because it's run out of room. They're going to be receiving a much higher nutritive quality of care in a swarming situation. That said, you got to do what you got to do. So if you need a new queen and all you've got are emergency cells, then you're going to use those. But if you have a choice, maybe go with the swarm cells. Okay, so let's talk about grafting for a minute. So this is something that is super, super heavy on the details. And I've taught at the queen rearing workshop for every single year it's been in existence, which is 5? I'm getting old. But you really need a lot of details for grafting, and one of those details is the materials you have. So a spray bottle to keep everything at your grafting station humid, grafting tools, flashlight, queen cages, queen markers, etc., etc. It's also a lot of details to keep track of in the bee side of things. You have to have graftable brood. You've got to have enough brood to make cell builders and mating nukes, which we'll talk about in a sec. You've also got to have a lot of stuff just inherently that's you. You've got to have patience, because learning to graft is something that requires patience. You've got to have fairly good eyesight so that you can see those very little larvae. You've got to have lots of water if you're in Texas. There's a lot of details involved. So I'm just going to give you a quick overview of this process. Grafting is not something that you're going to learn in a classroom over the course of an hour. But some of these things we've already talked about. So we select a mother colony from your apiary. What's the very best colony you have? That's the one you want to rear from. And I said that there's a lot of work that's been done showing that the nutritive care that a young queen receives has a big impact on her later in life, yes? Mm-hmm. So during every single step of this process, you feed the heck out of things, okay? So once you select a mother colony, start feeding it. And start feeding it with a lot of syrup, starting about 3 to 5 days before you're planning to graft from it. Then you get to make a cell builder. Now, I tend to make cell builders or starters with nuke boxes. So I typically, look at how full this is. See how many bees are in there? So a part of nutritive care is not just providing the food, it's also, well, how quickly does that young larva receive the food? Are there a lot of nurses in there? Are there a lot of nurses caring for each larva or not? That really, really matters. And so to ensure that each young larva has a lot of nurses, you pack that cell builder. You sort of simulate a swarming situation combined with a queenless situation. Does that make sense? Mm-hmm. And so if I'm building a 5-frame starter, I normally take between 10 and 12 frames of bees and brush them into that. That's a lot of bees. That's what I meant when I said this was a very expensive process, but there's more. So it's not just any bees that I'm brushing into a starter. Why is that? Nurse bees. It's nurse bees. So where do you find nurse bees? In the brood nest on the open brood. Where do you find a queen normally? In the brood nest in the open brood. So you gotta get real good at finding and locating the queen before you can do this. Because if you put a queen in your starter, it's gonna be a no-go from the very beginning. So we've made our cell builder and we've fed it. So we just went out to the bee yard, we just made our starter. It's the afternoon before our grafting day tomorrow morning. So next day, we go to our mother colony and we find a frame of very, very, very young open brood. So I don't know if you guys can see, and I don't know if this is thing. Okay, are you guys gonna fall asleep if I do this?
No. Hey.
Okay, I've got a clicker and I wouldn't throw it at you because it's quite heavy, but I wouldn't fantasize about throwing it at you. Okay, so see some of these? Despite this being a really good picture, it's still kind of hard to see. And that's kind of how it is in real life too, which stinks. But here you can see this is an egg, that's an egg. You can find eggs generally easier than you can find first instar larva, which is so ironic. But first instar larva is entomology speak for the first day that a young larva is a larva. The larva will go through several molts as they grow, and so those are each then a next instar. Honeybee larva, female honeybee larva, can be in the first, second, and third instars before the bees are like, no, 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 not okay. This is a worker larva. This cannot be raised as a queen. However, the younger a larva you select, the higher quality that queen may be. And that's partly because she's receiving a honeybee queen diet from an earlier point than those older larvae are. Does that make sense? So then this would be the perfect graftable larva. Can you see it? Because I don't think I could if I was you. But it's basically a tiny larva that if you stretched it out, it would cover about a third of the diameter of a worker hexagon. Does that put things into perspective? Yeah. So those are what you want to graft. And that's going to take a lot of practice to find them. And sometimes it helps to look around where there's royal jelly. You can see a glint of royal jelly easier than you can see the larva sometimes. So now you actually get to the physical process of grafting, where you take your grafting tool, and this is, do you understand what this is showing? It's the side view of a worker cell with the larva that's on a pool of royal jelly in it. Does that make sense? So if my hand were that same thing, you take your grafting tool in, and you come down along the side of the wall in kind of a J motion, and you slide under that pool of royal jelly and carefully lift up the larva straight out so that that larva and that royal jelly does not touch the cell wall. Does that make sense? Then to get her out, you kind of do the exact reverse. So you put her in, and in this reverse J motion, you kind of, with a stainless steel grafting tool, which is just a little flattened end to the tool, you kind of very carefully, my words are failing me, scrape her off on the bottom almost.
Slide.
Yeah, slide her off maybe. It helps if they're on a big pool of royal jelly. And how can you ensure that that happens? If you fed the mother colony before you're doing this, then you've ensured that they've got a good amount of royal jelly in there. If you're using what's known here as the Chinese grafting tool, which is actually what I personally prefer, although Dr. Rangel prefers the other one, then you pick up the larva the same way, but when you take her off that tool and put her in a queen cup, you get the tip of the tool to the middle of the bottom of the cup, and then you depress the plunger on that tool. And both work, it's whatever you get used to. So now you've grafted. Ooh, and here's a good reminder. Are you gonna graft so now, bear with me, we've jumped in time. Yesterday afternoon, we went out to the bee yard and we made our cell builder. But this morning, which is right now, was when we picked out our frame of very young brood. Where are we going to graft? Are we gonna come in here into this lovely air-conditioned space to graft? Or are we gonna go somewhere else? We're gonna go somewhere else. Why? Well, how humid do honeybees keep a colony? About 85%. That's that biology part again. It'll always be important. How hot do bees typically keep the colony. 92 to 94. If you bring that larva into a very air-conditioned, very non-humid space, you're really shocking that larva. It's better to do it outside if you can. So then, once we've grafted, we put those grafts into our cell builder and we feed it again. And then comes the hardest part, y'all. We gotta wait. We gotta wait for so long, for forever. How long do we wait? Think about that biology. Yeah, so we wait until our first instar grafts are in their third, maybe the fourth instar. So 2-3 days later. And then we move those grafts from the cell builder to what's known as a finisher colony. So this is a queen-right finisher colony, where the queen is in the bottom, and we've got a queen excluder here. We've got 2 honey supers, and then we've got a hive body up here that we put open brood in. Why would we do that?
Bring nurse bees.
Yeah, to bring the nurse bees up. And so we put our grafts in that top, far away from the queen in the bottom. Why would that be? Because the queen's pheromone is down there. And so if the grafts are further away in those queen cups, the workers are more inclined to continue to believe that imaginary scenario that we're tricking them into believing. The bees are more inclined to be like, oh yeah, we are queenless. And here are all the queen cells. Okay, okay. So remember when I said grafting had an unforgiving timeline? This is an example of a calendar where you kind of start plotting this out. And, ooh, where are, sorry, I will go back, I promise. The reason this is a very unforgiving timeline is because of this process. What are these?
Queen cells.
These are empty queen cells, yeah. If you go into your cell finisher and it's the 15th day or the 14th day of her life, and you know that because you grafted her on the 4th day of her life when she was a first instar, and you see this, well, what do? Well, you swear a bit,
Yeah.
maybe cry, I don't know. Because if you see this, it means a queen has emerged. And then most of your other grafts are probably gonna look like this, which means what? She went through and she killed him. So, wow, that kind of means that that timeline's pretty important, huh? So if you graft one day, can you go on your vacation for 3 weeks the next day? It's not gonna go well, guys. So plot out your timeline ahead of time. Use a calendar if you have to, but keep that biology in mind. When is she going to emerge? Okay, when should I cage her so that even if I'm wrong by a couple of days, it'll be okay? When will they be capped? When is the soonest I can cage? So this is sort of what the caging setup that we use is. We use these roller cages, and in this picture they have fancy caps on their roller cages, and we don't do that. But we do have roller cages where when the queens emerge in these cages, they can't get to each other, they can't get out. Oh, and they're on a baking frame in a colony where they can be cared for adequately. So I cage my queens 9 or 10 days after I graft. So when is that in that biology period? She's a pupa. Yeah, that's about so if she's an egg for 3 days, and then I graft on the 4th day, and then I wait 9 to 10 days, how old is she? How many days old is she? Yeah, somewhere in there. And so she should be emerging in the next couple of days. The reason I wait that long to cage rather than just caging on the very first day that she should be capped is because pre-pupa and pupa are very, very delicate at the beginning. They've got their head end, or no, they've got their abdomen end in what's left of the royal jelly, but they need to be able to access that royal jelly, and if their cell is jostled too much, they'll fall to the bottom of the capped cell, and then they can't get back up to eat that royal jelly, and so that's called slumping, and that kind of generally means that that queen won't make it. Okay, so we've caged all the capped cells, we've put the queens in a maiden new growth queen bank. Life is good. Now we can check the work with some of the assessment techniques that we learned before. But the other thing to think about is, okay, so this is your first time grafting. We've jumped in the timeline again in our fabulous time machine. Our graft was hugely successful. 100% of the grafts that we did made it, guys. Woo! Congratulations. So you are one of the smaller scale beekeepers in the room. You have 10 colonies, like you wanted to graft. And you weren't banking on your grafting skills being as incredible as they are. And so you weren't planning on getting 100% take, but you grafted 60 grafts. Woo! Do you have enough bees to make 60 mating nukes?
Probably not.
Enough for 60, hopefully. Yeah, that's a lot of bees that you need to get your hands on, and a lot of equipment that you need to get your hands on if you're going to use all of those virgins. So now might be a good time to cull out some of those cells. How do you do that? Well, just like we assessed the queens earlier, now we can assess the cells. And we can do that again with destructive or non-destructive techniques. So we can open the cell. We can open it and look and be like, well, okay, I know that these should be pre-pupa today. Are they all pre-pupa, or are some actual pupa? Maybe those are the older ones. But this is pretty destructive. So are any of the cells that you opened up gonna be good queens? Probably not. I have seen someone open a cell a little bit, put it back together, and had a queen emerge from that. But that's not something I would recommend. There are non-destructive ways of assessing queen cells, like looking at the length and shape of the cell and making sure to keep track of the emergent states. So this is your gorgeous, glorious 100 take grafting cell. Which cells would you take out? Would you keep or cull this one? Oh, I would keep it. It's so gorgeous. It's big, hopefully she'll be big. It's straight, and for whatever reason, it seems like the straighter cells end up having bigger queens, and I don't know why that is. But what about this cell? Would you keep it or toss it? Yeah, chances are pretty good that she's in the bottom and that she's slumped and is away from the food anyway. I would toss that one. What about, well, there aren't many here, but this is kind of this is maybe the shortest, stubbiest one. These two. Would you keep those or toss those? I toss those. So, I mean, call out cells, guys. And then don't forget to cage. You gotta cage. But even if you don't cage and you see this, then you learn something very interesting. What do you learn if you've been compulsively keeping track of the timeline, but you still see this when you go in to cage your cells 9 days after you grafted? Yeah, this means you were grafting third instar. You grafted a third instar larva here rather than a first instar larva. She's 2 days older than she should be, right? So that means you need to practice your grafting a bit more. So now, let's talk for a minute about some of the things you can control here and some of the things that you can't. So we've talked about queen assessments a little bit, but how do they get good or bad? You know, how do they get to be those really good queens that you are proud and excited to breed? Well, the very first thing that you can control is the age of that grafted larva. You think you can easily do that? I do. I do. I have 100% faith that you can easily do that if you are going to graft. I also have some faith that it might take some of you some practice, perhaps more practice than others, but you can do it. You have my complete faith. How about nutrition? We already said that when we talk about nutrition in queens, it's not just the quantity of nutrition that they're getting, but also how quickly they're being fed royal jelly by the nurses. Can you control nutrition? Yeah, you can have an impact on nutrition. You probably can't control it 100% of the way, but you can certainly have an impact on it by feeding a lot to the colonies you're going to be using and to your starter and finisher. What about the quality of the drones? Can you control that?
No.
Not normally, not unless you're going to inseminate. Dr. Delaplane mentioned that he really advocates that clubs and groups band together and get insemination equipment so that you can control this. Drones are half of the equation, and you are only controlling half the equation by selecting the queen from a mother colony that is a good one. Does that make sense? There are ways that you can try and stack the deck a little bit without inseminating. One of those ways would be to set up out apiaries. So again, look at the biology. Queens travel further from their colonies to mate than drones do. So around your queen rearing apiary, go about a half mile and start setting up out apiaries. And in those out apiaries, in the best colonies in those yards, maybe put some drone frames in there. Seed that area with drones that have the traits that you like. And that is not a foolproof plan, but it is stacking the deck slightly more in your favor. And as you may have gleaned from my cheating method of queen rearing, I'm an advocate of cheating at every step of this queen rearing process that you can. The bees are never going to kick you out of the bee yard for cheating the way your poker buddies would, okay? Now, again, I would be remiss if I did not mention a little bit of my dissertation work. My dissertation work centers around colony contamination, and my special interest that my dissertation is built around is looking at in-hive contamination and how it impacts queens. Now, contamination, that's kind of a funny word. What do I mean by that? I mean pesticide contamination and things of that nature. So there are two ways that pesticides can get into your colony. They can get into your colony because foragers went out to a field somewhere that had pesticides in it, and those foragers brought those pesticides back in their nectar and pollen. Or, as a beekeeper, we introduced pesticides to our colony. And we do that all the time when we control varroa mites. And in good conscience, I cannot advocate that you absolutely go organic. I cannot advocate for that because the vast majority of organic beekeeping operations have extremely high levels of colony mortality. And as a beekeeper my undergraduate tuition was paid by, well, a third of it was paid by honey proceeds. I'm a beekeeper. When I started doing this, I got very excited. I was like, okay, so my results are pointing to the idea that the pesticides that we introduced to colonies are having a negative impact on the queen. So I'm not going to use any miticides this year. It's possible to do that. It takes a lot of work, takes a lot of growing pains. It's simply not something that we can do at every single apiary scale. So that said, we can't completely keep our colonies chemical free, not from colony contamination, but also not from in. Even if, say, we do completely go the non-chemical route, the foundation that we buy is coated in wax or made with wax from our beekeeping community and the beekeeping industry. Even if we decide to go completely organic, has everyone? No. You're always going to have some levels of contamination in your colony. But again, you can cheat. You can stack that deck. And you can do that by culling out old frames in your operation and playing the concentrations game. Keep the concentrations of pesticides in your colonies as low as you can, particularly in the colonies where you're rearing queens. Does that make sense? Okay, and we are basically out of time, so without further ado, I would like to thank my funding sources and the people that have supported me during my PhD. You are welcome to email me with questions. I think we might have a couple of minutes for questions, but I'm not sure. So have at me, guys. Thanks so much for your attention, too.
When you're assessing your cells, do you handle them?
I don't.